How on earth does your phone tell your headphones to full blast music and destroy your eardrums when they're not even connected? Well, it all happens through Bluetooth, which may as well be magic invented by dark sorcerers. Except this magic travels through waves. No, not those waves. Light waves. Well, sort of. Radio waves. Turns out, your eyes are pretty blind. Sure, you can see red and green, but those wavelengths are tiny. Like, nanometer level tiny. Bluetooth uses centimeter range waves, basically 1,000,000 times longer. So long they pass through walls. Not sure how, but yeah, they do that. So, anyways, first your phone and headphones have to pair using these weird radio waves. Your phone's Bluetooth chip sends out a signal using something called Gaussian frequency shift keying. Yep, big words, I know. The Gaussian bit is kind of irrelevant. It just smooths things out so the signal doesn't look like a toddler's drawing, which actually makes it pretty relevant, but whatever. The frequency shift keying is the interesting part. All data is represented as ones and zeros. That's binary. For example, if I wanted to write "you should subscribe" in binary, it would look like this. The chip uses two frequencies, which are both in the same Bluetooth band, to send data. Chill, I'll explain bands in a second, just wait, okay? One frequency stands for 0, and another for 1. So to send data, the chip flips between them, about 1,000,000 times per second. That's pretty fast. It also starts each data packet with something called a preamble. This is a known pattern of ones and zeros that tells your headphones, hey, I've got something to say, so listen up. Then it sends its device address, basically yelling its name, along with some other stuff. The Bluetooth chip in your headphones then does as told, and listens for changes in frequency to decode the message. It then uses cyclic redundancy checking, which is just a fancy word for spell check, to make sure your phone actually sent it a message. If the message passes the spell check, your headphones can then respond and say, hey, let's be friends. Okay, cool. Got it? But don't get too excited, because you can't start listening to your Taylor Swift yet. If this was all Bluetooth did, everyone else would also be able to hear your music, and you'd be able to hear everyone else's music. Not cool. Your phone and headphones need to establish a private link. How? Maths. Let's say your phone is called Alice and your headphones are now Bob. The problem is, both Alice and Bob hang around the 2.4 GHz ISM band, which is basically a busy concert of TVs, microwaves, and everyone else's phones and headphones. Fine, I should probably explain bands now. A band literally just means a slice of frequencies. In this case, the 2.4 GHz ISM band is about 83.5 MHz wide. The ISM bit just means industrial, scientific, and medical. Pretty irrelevant. Alice wants to tell Bob to subscribe, but she doesn't want the nosy kid Dave to hear. So Alice comes up with a private number. Literally, just a random number. Then does some simple maths to it. Like elliptic curves over large prime fields. Nothing too crazy. This gives her a public number. Bob also comes up with his own random private number, and then does the same. Alice and Bob then swap their public numbers, and combine these with their own private numbers to arrive at the same answer, which they use as an encryption key. How? Maths. Yeah, I don't even know. Just accept it, okay? It's called the elliptic curve Diffie-Hellman protocol, and since neither of them ever shared their private number, Dave can't figure out the encryption key. Keeping up so far? Good. Alice now combines her message of subscribing with this encryption key, and uses a method called AES encryption. Just more simple maths like matrix shuffling and bit substitutions. You know, primary school stuff. To produce complete nonsense, she sends this nonsense to Bob, who uses that encryption key to decode her original message. Since Dave doesn't have the encryption key, all he hears is complete gibberish. And just to make it even harder for Dave to snoop, your phone and headphones swap bands about 1600 times per second, using a technique called frequency hopping. Bluetooth is divided into 79 bands between 2.402 GHz and 2.480 GHz, each one 1 MHz wide. Your phone and headphones randomly pick a channel to jump to, 1600 times a second. Well, not randomly. When they first pair, your phone sends your headphones its device address, and some timing data. And guess what? Tells it to do some maths. Both devices do the same maths to that data, and that gives them an order of channels to jump to. It's all predictable, but since no other device has that timing data, it's also private between your phone and headphones. All this jumping makes it literally impossible for Dave to hear any part of your Taylor Swift song. So yeah, Bluetooth is dark magic. Enjoy your Taylor Swift, and hey, subscribe.